23、22、21、20、19、18、17、16、15、14、13、12、
Flight mode on.
10、
The flight mode is on. Viola Würdemann. The thermal batteries have been activated. 全システム準備完了。All systems are go. Main engine start. The main engine ignition. Further delay got lift off. Solid boosters ignited. Lift off. プリズムスリムを搭載した H2A ロケット47号機は2023年9月7日午前8時40。
And with that, hello and welcome to my video. My name is Viola Würdemann and this video is part of the Seminar Planetary Exploration. The topic of this video is SLIM, a quite recent lunar mission of Japan. You just saw the start of this mission. SLIM is short for Smart Lander for Investigating Moon and was a mission of the Japan Aerospace Exploration Agency, short JAXA. The main goal of this mission was to test a new pinpoint landing technology and also to cutting weight for higher function observational equipment. With the landing technology, JAXA wanted to ensure that a lander would only land up to 100 meters away from the planned landing site. The traditional areas of probable landing have the shape of an ellipse, which is several kilometers long and wide. The difference between the traditional landing zones and the targeted landing zone of JAXA is, as you can see, very large. Because of this rather small landing zone, SLIM is also called the Moon Sniper. But as I already said, this technology was not the only thing JAXA wanted to test. The lightweight lunar and planetary probe system was developed to allow more frequent lunar and planetary exploration missions. However, not only the goals of that mission were special. This mission had some interesting special features. After 2 missions that crashed, SLIM made a safe landing on the Moon. With that, Japan became the 5th nation to do so. Before Japan, a safe landing was only mastered by the USA, the Soviet Union, China, and India. SLIM had also 2 unusual rovers on board, Lunar Execution Vehicle 1 and 2. These rovers were Japan's first lunar exploration rovers. The planned landing position was near the Scioli crater on the near side of the Moon. This position was chosen for its science potential. The launch date was on the 6th of September 2023 and 2342 UTC. SLIM entered the lunar orbit on 25th of December 2023 and landed on the Moon on 19th of January 2024 at 1520 UTC. Now that I've told you about the special landing technology, I'd like to tell you about the actual landing process. SLIM had preloaded data from the Japan's Kaguya lunar orbiter, that's also called SELENE. This data were mainly maps and images of the surface of the Moon. SLIM could now compare this preloaded data with the data it collected while descending. It would search for matching craters and other distinctive surface structures. With that, it could locate itself and guide the spacecraft to the landing site. Because this comparing process had to happen autonomously and very quickly, JAXA had developed special image processing algorithms. Furthermore, SLIM had a landing radar and a laser rangefinder for determining the altitude during the descent and for recognizing obstacles. If it would recognize an obstacle, it would move then horizontally out of the way. Before SLIM finally landed on the lunar surface, the 2 rovers were dropped. In the end, SLIM landed about 55 meters east of the original targeted landing site. Unfortunately, SLIM has landed in the right place, but not in the right position. It landed 90 degrees from how it should be. That happened because one of the 2 main engines was most likely lost. The big problem that came with this landing position was that the solar panels were oriented westwards, in other words, to the opposite direction to the position of the Sun at the start of the lunar day. That means that SLIM was unable to generate enough power to operate properly. Hereafter, I want to show you a simulation of the landing of SLIM. There you can perfectly see the obstacle avoidance of the lander, the dropping of the rovers, and the landing on the surface of the Moon. In this picture, you can see the final steps of the landing as it was planned. The steps for the stabilization did not go as they should have, and so SLIM landed on its head. Here you can see the actual landing position of SLIM. This picture was taken by Lunar Excursion Vehicle 2, one of the rovers of this mission. In case you wondered what these strange stripes in the center of the image are, they are caused by data loss. Luckily, the mission didn't end after the unfortunate landing. SLIM operated on the internal battery power for a short period of time, but was then manually powered down after approximately 2.5 hours after the landing. Meanwhile, the rovers operated autonomously as it was planned. JAXA re-established contact to SLIM at the 28th of January. That was possible because it was the end of the lunar day and the lighting conditions shifted so that the sunlight could reach the solar panels. But soon after that, JAXA had to put SLIM into sleep mode to protect it from the coming harsh lunar night. In fact, SLIM was expected to operate only for one lunar day. That is approximately 14 Earth days, because the electronics were not designed to withstand the lunar night that can get as cold as minus 120 degrees Celsius. But surprisingly, the lander survived that lunar night, and JAXA was able to re-establish contact on the 25th of February again. That was quite unexpected, since there were just a few landers of the Soviet program that survived the lunar night without a radioisotope heater unit before. But not only that SLIM survived one lunar night, it managed to survive another 2 lunar nights, which makes it 3 survived lunar nights in total. SLIM woke up on 27th of March and on 23rd of April again, had a connection to the Earth and operated for a few Earth days. but after each night the electronics on SLIM were more and more damaged, so it wasn't a big surprise that JAXA couldn't make contact to SLIM after the fourth lunar night. They tried it also up to the fifth, but even then they were unsuccessful. SLIM most likely died in its fourth lunar night on the moon. Before I will talk about the rovers, I want to tell you something about the operations that SLIM performed, except for the landing and the communication to Earth. SLIM landed near the Scioli crater because there's a suggestion that there might be the mineral olivine and that it is exposed on Scioli's slopes. That is important because it might be material ejected from within the moon's mantle that could tell us something about the formation and the evolution of the moon. SLIM had a multi-band camera on board that can find and determine the composition of olivine by analyzing the spectra of sunlight reflected off the olivine. On the left side you can see an image that was made by this specific camera. The gray part on the edges is a lack of data that is caused by the discontinuation of scanning operation. This is the same picture in a close-up. The marked rocks are rocks of interest for the researchers. They named the rocks, communicating their sizes smoothly by the names. But now to the rovers. Both of them are quite interesting and unconventional. You can see them in the picture. The left rover is the Lunar Execution Vehicle 1, or LEV-1 for short. The smaller ball-shaped one is a Lunar Execution Vehicle 2, or LEV-2. But first I'm going to talk about LEV-1. For the movement, LEV-1 has a hopping mechanism. That means it hopped across the surface of the moon like a frog. In total, it made 7 hops over 107 minutes. It had a wide-angle optical camera and a direct-to-Earth communicator equipped. The main goal of this rover was to test this direct-to-Earth communicator. After it successfully established a connection to Earth, it became the smallest and lightest communication device that made a connection over 380,000 kilometers. In this clip, you will see how LEV-1 moved. You can also see the metal foot with which it could make the hops. Now to LEV-2, or as it also is called, SORA-Q. As you already saw, this rover is quite small. It was only palm-sized, had a diameter of 8 centimeters, and weighs only about 250 grams. SORA-Q was developed by JAXA in collaboration with the Japanese toy company Tomy, Sony, and the Doshisha University. It was also on the Hakuto-R Mission 1, but it crashed, so the rover couldn't be tested. The equipment of SORA-Q consisted of 2 cameras and a stabilizer. You can see the cameras in the picture. They are the orange part in the center of the rover. The goal of SORA-Q was to take photos, like the one of SLIM after the landing that I showed you in the beginning of this video, but also to inspire children to pursue their interests in science and space exploration. You're probably wondering how this little ball-shaped rover is moving. I will now show you a video contribution of the Malaysian daily newspaper The Star. There you will see the movement of SORA-Q.
れが持っているそのおもちゃの技術というところが宇宙の探査に活かせるんじゃないかといったところから取り組みを始めました。今この探査月面ロボットが宇宙に行くことで遠い宇宙のことをより皆さんに身近に感じてもらって宇宙に興味関心を特に子どもたちに持ってもらいたいなと思っています。
This movement is inspired by sea turtles and frogs, and left 2 can move about 2 hours. In total, we can say that the mission was quite successful. JAXA declared that they are going to use the precision landing technology for their future missions like the Martian moon exploration and their lunar polar missions. They hope that this technology helps to shift the standards of lunar landing missions. To say in their words, from the era of landing where we can to landing where we want. But not only for JAXA, this technology might be useful, but also for the rest of the world. There's a growing global interest in the moon. That means the lunar exploration advances, and so will the need to target specific sites for answering science questions. And this landing technology can be also used for other planets and moons, like for example Mars. Both rovers also successfully achieved their goals, especially LOVE 1 with its direct-to-Earth communicator will also be used in JAXA's future missions. Before I get to the end of this video, I want you to show the promotion for the SORA-Q model from the toy company Tomy. As I told you, the goal of SORA-Q was not only to take pictures but also to inspire children. The toy company Tomy was also involved in the development of this rover. Now they are selling the true to original model. Here you can see a screenshot of the website. If you are interested in this model or the rover, I can recommend visiting this website. You will see the link in my references under the point 11, or you search SORA-Q in Google and click on the link from the company Tomy. On the website, you will also find more information about the rover itself. At last, I'm going to show you the promotional video for SORA-Q.
月の表面を覆うレゴリスはどんなものなのか。月面で探査機はどのような挙動をするのか。月の探求が宇宙探査のさらなる発展へとつながる。変形型月面ロボット、その名もSORA-Q。SORA-Qは JAXA、タカラトミー、ソニーグループ、同志社大学の共同開発によって生まれた超小型の変形型月面ロボット。玩具開発で培われた技術によって超小型、超軽量を実現した変形型月面ロボットである。スリムが月面に着陸する際に月面へ放出されるSORA-Q。球体のまま着陸すると変形を開始。走行可能な探査機へとその姿を変える。左右の車輪を自在に動かし、月の歴史を掘り起こしていく。2種類の走行モードが平地だけでなく、レゴリスの傾斜地での走行も可能にした。前後に搭載されたカメラ。前方のカメラで着陸機や周囲の状況を、後方のカメラでは轍などを撮影。宇宙への疑問がまた一歩解明されるかもしれない。
I'm now at the end of my video. You can see here the references I used. The links with the numbers in front are the references where I have the pictures and the videos from. Thank you for your attention. I hope you like this video and learned something new about space exploration and lunar missions.